Okay, let's get started on our quick review of everything we've learned in science so far. We've started out here learning about motion and how things have moved. The first thing we learned was frame of reference, and this is how we tell something's moved. Frame of reference is all those objects in the background that aren't moving. We use those to tell if something moved. Check out this pretty neat video for frame of reference. Now, how can you tell the car is moving? And what's our frame of reference? Well, we can look out and we can see the cars and the parking lot. We can even see a building and maybe even some big poles. These are our frame of reference in this picture. Those objects aren't moving, and those help us to understand that we are in fact the one in the car moving. Now, I guess the whole world could be moving, and just this car is standing still, but I doubt it. So after frame of reference, we started doing labs that involved us to move around, doing different types of motions. And we learned a new formula, and that's how to calculate speed. We learned that speed is distance divided by time, and that tells us how fast we're going. So when we walked backwards and we skipped and we jumped and hopped and did backflips and all the other good stuff, we were calculating speed. The way you calculate speed is distance divided by time. So here's a pretty neat little picture to help us keep it straight. If we need to find speed, this one, all you need to do is distance divided by time. Now this little picture can help us find all three of these things. If you need to find distance, all you need to do is take speed and multiply by time. And if you want to find how long it took somebody to do something, all you got to do is distance divided by speed. Pretty easy, eh? Now just today, some of us started to look at how to calculate the average speed, and we needed a quick reminder of what it means to calculate an average. Now, to find the average of numbers, you add all those numbers together and you divide it by the total amount of numbers you had. So here's an example. If you have three numbers, 4, 8, and 9, to find the average, you add them together, 4 plus 8 plus 9, and then you divide by how many numbers you have, 1, 2, 3. Check it out. It's pretty easy. So after we learned about average, and actually this whole time, we've been learning about this thing called scientific method. Scientific method is a way that scientists solve problems. It's kind of like their strategy for solving problems and coming up with solutions and creating new things. It's got a purpose, an information section, hypothesis, procedure, results, conclusions, and possible errors. Now, a purpose statement is what you're doing and why you're doing it. It usually starts with something like, to find out. But a good purpose statement has lots of details, and they've got a reason for what they're doing. The next step is information. Information, this is where we write down any of our past experiences and prior knowledge that are going to help us to understand how to do the experiment, or maybe even understand the results. After that, we look at all the information we have and we come up with a hypothesis. Hypothesis is our educated guess for what we think is going to happen, or what we think the results are going to be based on the information that we know. After our hypothesis, we have to come up with a procedure. And the procedure is all the steps that we're going to actually do in our experiment. So it's step by steps, kind of like the directions. Now, good procedures are easy to follow. After procedure, we collect all of the data, and we include that in what we call the results section. The results are where all of our data tables and graphs and all of the actual numbers go. Now, after we've got all these numbers and data, we then start coming to some conclusions. We look at all the observations and all of the data and all the numbers, and we start to try and find patterns and come to a few conclusions about what happened in our experiment. Now, once we're done with our conclusions and we've come up with what has happened, it's always good to write down some possible errors, because you know what? Sometimes things just didn't work out right. But that's okay. And that's what possible errors are for. These are what help us to understand what happened in your experiment. So hopefully this has been a good quick review of what we've learned in science so far. keep looking at EDU 2.0 for any more posted assignments. All right, see you soon.